Welcome to question 3b of our assignment, our tutorial sheet. So we see that we have F1, F2 and F3, and in here they've given us the angles with respect to the XY plane, also the angles with respect to the axes X and Y. So those are the angles we are supposed to use to find the components, and then we sum the components together. You just have to visualize it properly. Okay? So without further ado, we'll just make sure that we do what we are supposed to do here. So I know that Frx will be equal to, I'll start with F1, which is 10, isn't it? And then I need the X component. So I need to find F1 prime first by saying F1 prime is equal to F1 cos 26. And then using that F1 prime, I'll do again cos 42 to find the Fx. So I'll just write it here. So you have cos 26 degrees times cos 42 degrees. So this will give me, for F1, it will give me the X component. Okay? Sorry, we are trying to be a little bit fast. For the F2, I've seen that the component of X for F2 is a negative because it has that component going beyond the origin there. So I'll have minus 16, then I'll find from the angles given. I've been given that 35 degrees, so it's sine 35, and then to find the F2 prime, it's cos 40, and then I do the sine 35. So I have 16 times cos 40 degrees, and then multiplied by sine 35 degrees. Okay, and then I have the Z, which will just be what will be okay, sorry, for F3, not the Z, but for F3, yes, because all these we are summing are the X components. Okay, so for F3, the X component will be F3 cos 50 and then again cos 60. So it will be plus 20 cos 50 degrees and then cos 60 degrees. Now you can go ahead and express each of the forces in Cartesian vector form and then add the i's, the j's and the k's. That's probably what you have learned in class, and that is what you're supposed to do. But I just want to show you that there are these other cheats which are essentially the same, but you can also cheat it this way. So with this, we see that we will have to calculate that there. So I have 6.077. This should be kilonewtons. Okay. So my F ry is equal to, basically it will be the same, except where I was putting that second cos I need to put the sine, and where I was putting the second sine I need to put the cos. Yeah, and see the direction, whether it's negative or positive. So for f1 and f2 I see their y components are negative, so it will be negative 10 cos 26 degrees, then I have sine 42 degrees minus 16, okay, cos 40 degrees, and then I have again cos 35 degrees, and then I have to, my z component will be a plus 20 cos 50 degrees sine 60 degrees, sine 60 degrees. Oh, sorry, the degree is looking like a 6. It's not a 6, it's a degree, it's just the writing problem. If you've done your calculation very well, this should give you minus 4.921 kilonewtons. FZ, FRZ, sorry, is equal to, this will just be 10 sine 26 plus 16 sine 40 degrees, and then plus 20 sine 50 degrees, which is equal to, this will be the 29.99 kilonewtons. So these are our answers. Answer, and answer. Okay. Now what we need to do is to write it in okay, sorry, these are not really our answers. What we need is to write it in what? What we need to is to write it in Cartesian vector form. Oh no, what we are being told is to find the magnitude. So magnitude FR mag is equal to the square root of 6.077 squared. This is 0, and then plus negative 4.92 squared plus 29.99 squared, and this will give us a whopping 30.992 newtons. Okay, since we have gotten the magnitude, well, getting the direction angles is not, come on, getting the direction angles is not tricky now, because we know that alpha will be equal to cos inverse of 6.077 over 30.992, which is equal to 78.7 degrees. Beta is equal to cos inverse of minus 4.92 over 30.992. This will be 99.1 degrees. Gamma is equal to cos inverse of 29.99 over 30.992, which is equal to 44.1 degrees. Thus, we have the direction, angles, and the magnitude of the resultant. Magnitude is this one. So these are not answers. The answer and then the answers are these. Thank you.